Hi, it's Mrs. Cat here to work through another stoichiometry limiting reactant example with you. So we're going to take a look at this problem. If 90 grams of iron 3 chloride reacts with 52.0 grams of hydrogen sulfide according to the provided reaction, answer the following questions. So for a reaction, we've got 2 iron 3 chlorides and 3 hydrogen sulfides reacting to form 6 HCl, which is hydrogen chloride, and 1 iron 3 sulfide. Things we want to know: what's the limiting reactant, the mass of hydrochloric acid or HCl that's produced, and how much the mass of the excess reactant that remains after the reaction. So once again, we're going to be using BCA table method to help us solve this problem. So I'm going to start by setting that up. I'm going to rewrite my equation so I've got a little bit more workspace. 2 FeCl3 plus 3 H2S. It's going to give us 6 HCl, plus Fe2S3. Okay, BCA. Once again, I like to put in my dividing line. No moles of reactant to start, but we're going to add to form that and subtract product to make that happen. Before we fill out our BCA table, we want to make sure that we convert into moles of each of our reactants. I'm going to shortcut this a little bit, and I'm going to give you the molar masses of these two reactants. I'm just going to write them here in the problem. We've got a molar mass of the iron 3 chloride is 162.20 grams per mole, and the H2S is going to be 34.09 grams per mole. Now I got that by each of those by taking the masses off the periodic table and adding them up. I'm going to use those to set up a proportion to find the moles of each of my reactants, starting with the iron chloride. So I've got 162.20 grams of iron 3 chloride for every 1 mole, and that's going to equal 90.0 grams. We're looking for moles. Okay, so we're going to cross multiply, divide, and we're going to end up with, let's see here, 0.5549 moles FeCl3. Go ahead and place that in the BCA table. 0.5549 moles. Same thing, second reactant. This time our H2S, we're going to use 34.09 grams for 1 mole. And this time we have 52.0 grams H2S. Looking for moles. Cross multiply, divide to find our X. And here we're going to end up with 1.525 moles of H2S. Now, notice here, again, I don't want to take any fewer significant figures into my BCA table than I have in the problem. I actually like to take 1 or 2 more, which is why I'm taking 4. So I'm going to add that into my table, 1.525 moles. Okay, so to figure out what is our limiting reactant, we want to set up a proportion and figure out what we've got happening with these two reactants. So this time what I want to do is I'm going to use a proportion to solve for how much HCl each of these reactants can produce. And I want to use that mole value. If I solve it this way, I'm looking for which one gives me the smaller value for the HCl. So I'm going to use each of these, starting with the iron chloride. I have 2 moles of FeCl3 in the reaction, which will make 6 moles of HCl. And I know that I have 0.5549 moles of FeCl3, and I want to find out how many moles of HCl that can make. Okay, cross multiply, divide to find the moles of HCl. We're going to take our moles times 6 divided by 2, and this is going to give me 1.6647 moles of HCl. Okay. Now, looking at the iron chloride, or not the iron chloride, the H2S hydrogen sulfide, I know I have 3 moles of H2S. That also makes 6 moles of HCl. This time I have 1.525 moles available of the hydrogen sulfide, H2S, and we're looking for how many moles of HCl that'll actually produce. So, cross multiply, divide. We're going to take our moles of H2S times 6 divided by 3, which is going to give me, let's see here, 3.050 moles HCl. Okay, so these are the two numbers that we want to compare. I'm going to take a second and highlight these. So what we want to do is look at these two numbers, and the smaller value is going to be the amount that is actually going to be produced. Okay, so that's going to be our 1.6647 moles. Okay, this is our theoretical yield, and this is in moles, obviously. Okay, this tells us that the reactant we used to form that number of moles, which for us is our iron chloride, that is going to be our limiting reactant. Okay, so that is FeCl3. We're going to use up all of that iron chloride. Now that we know that, we can go back into our BCA table and fill in what we know. So we know that the iron chloride is going to be our limiting reactant, so we're going to use up all the moles of that, 0.5549. Okay, we also know how many moles of HCl we can produce, which is 1.6647. And we know that's what we're going to add in here, 1.6647 moles. Okay. So now to finish out our BCA table, we need to do 2 more proportions to solve for the change of H2S and how much of that excess is left over, and then the iron 3 sulfide. So I'm going to throw these proportions over here right underneath my BCA table. So I'm going to use my limiting reactant to find those 2 remaining proportions. So 2 moles of FeCl3 for 3 moles of H2S. Again, we're going to use 0.5549 moles of H2S. Or, that's not H2S, is it? That is FeCl3, and we're looking for moles of H2S. Okay, cross multiply and divide to solve for x. we're going to get x equals 1 point, nope, x equals 0.83235 moles. Okay, I'm going to go ahead and put that in my change line. We're going to subtract that, minus 0.83235 moles, and then I can go ahead and evaluate to find out how much of that H2S is going to be left over. 1.525 minus that 0.83235 is going to give me 0.69265 moles left over. Okay, we'll convert that into grams in just a minute to find out question number 3. Okay, last proportion. See if I can squeeze it in. Let's do it here on the side. Okay, so we're looking for how much of that final product we can form. So, like I said, I'm going to try to squeeze this in. Maybe right here. Okay, 2 moles of FeCl3. Again, we got to use our limiting reactant because that's our determining factor for the product and how far the reaction can go before it's used up. Fe2S3, 0.5549 moles, x moles. Okay, cross multiply, divide. We're going to get x equals 0.27745 moles. And again, that is Fe2S3. Plug this into my BCA table for both the change and the after. 0.22745 moles in both places. Okay, so let's highlight what we have that we need to take for number 2 and number 3. And that is for number 2, the moles of our HCl that we're going to want to turn into grams. And then for number 3, our moles of excess that we're also going to want to turn into grams. Okay. I'm going to scroll down to give myself a little bit more space since I'm squishing everything in here. Leave those 2 values here. So let's take number 2. We're going to work that down here. So in number 2, I'm going to use the moles of HCl that were formed and turn that into grams. Okay, molar mass of HCl, again, I'm just going to give this to you, 36.46 grams per 1 mole. Again, that's coming straight from the periodic table. Add them up. Okay, we're looking for the number of grams in 1.6647 moles HCl. Okay, here, cross multiply and divide. We're going to want to round this to 3 significant figures in the end. So we're going to wind up with 60.7 grams of HCl that are going to be produced in this reaction. And then we can change colors here again. Let's go blue. The amount of excess that forms, we're going to change also from moles into grams. Okay, so I'm going to use that molar mass of H2S from before, 34.09 grams of H2S for every 1 mole. Okay. Here we've got 0.69265 moles H2S, and we're looking for grams. Cross multiply, divide, find our X, which is going to be 23.6 grams of hydrogen sulfide left over. Okay. Another example of limiting reactant stoichiometry using a BCA table. Make sure that when you are using those BCA tables that all your values are in moles, not in grams, and you have got to find that limiting reactant in order to determine the number of products, the moles of products that you form.